All right, class. Well, today, in case I'm not there because of the whole foot situation, just know that as soon as I'm back, we might have to do a little patch up and go from there. So, for warm up, what is the hypothesis and conclusion of the following statement? If you truly want to change your life, then you must be willing to change your outlook on life. So, what would the hypothesis and conclusion be? Remember, so give it a pause, give it a shot. Remember, the hypothesis follows the if, the conclusion follows the then. So, in this case, we're looking at it. We are going to be if you truly want to change your life, would be the hypothesis, then you must be willing to change your outlook on life. Those would be the two we're after in this case. All right? So today, do conditional statements, wordplay, both mathematics. May get a little bit more deep today, just a little heads up. So we're going to be looking at those ones, negation. So just know that when we're dealing with it, it will be also up here at the top. But what negation is basically saying the opposite of the original statements. So you start with the squiggly line, P. What it's really saying is not P. The other one we're going to be looking at today is called the inverse. This is obtained by negating both the hypothesis and conclusion. So basically, we're looking at the conditional statement and saying, not this, not this. That's all it's saying. So if not P, then not Q. The last one we'll be looking at today is the contrapositive. This is obtained by basically looking at the converse and saying, no, no. Not Q, just like a pure Q. Not P, just like a pure P. So we'll be seeing these and it will be up here for you to write down. All right? So, as you see, negation is right here. Not P, not Q. So, the Sable's taken book just doesn't affect, this was taken from the hypothesis. So this is negation. So notice what animals are in this photo. We have a couple cats, we have a couple dogs, gerbil, a fish, a rabbit, snake, a couple birds, and ferret by the looks of it. So, if we assume we're in the world of Disney, and one of the animals says this, I am in this photo, then I am a dog. Is this a true statement? Because let's just identify what we have. If then. Could the one talking be something else besides this dog and that dog? There's plenty of other options. So to negate, all we're going to do is apply that. So we're just negating. It's like if I'm talking so, then I'm not the dog. We're just negating the original statement. If I am rich, then I am happy. A lot of people think that as soon as you get all this money in the world, people will finally be happy. But that's the thing is, I know someone who was rich in Santa Rosa area. Was one of my aunts. She took a lot of cruises and things like this. And she always said that with all this money, she was also incredibly lonely. Because she didn't know if people liked her or for her money. So that's the thing with rich being rich. So if we're just negating P, if I am not rich, then I am happy. So that's just negating P, which is possible. Negating Q, if I'm rich, then I am not happy. That was more like my one aunt, my one great aunt in the Santa Rosa area. Then there's not P implies not Q. If I am not rich, then I am not happy, which is a lot of people believe like, oh, I need money to be happy, but I'm not happy right now. So a lot of people believe this when in all reality, money is just money. You can't bring it with you or anything like that. So you should be happy with what you have. That's all I'm going to say. That's how it's going to get deep today. All right? Because if you look at it, these two options are not happy because if you're rich or you're not rich, you're focused on one thing. So the inverse is obtained by negating both the hypothesis and the conclusion. So if we're going to create and evaluate the inverse of the following statement. If a shape has three sides, then the shape is a triangle. So we're going to first identify what our hypothesis and conclusion are, looking for the keywords, and then swap. Or not swap this, we're just creating an inverse, that's right. Same way. Sorry. If a shape does not have three sides, then the shape is not a triangle. Is that a true statement? I would say yes. So there's plenty of different ways to go through this one. You have to kind of string it together. So create an if-then statement for the following, and then create the inverse and evaluate. Two identical angles sum up to 180 degrees. We should know this because only a very unique case it applies to, actually. So if we have two identical angles, then the angles sum to 90 degrees. Or we can have two angles that sum up to 180 degrees, then the angles are identical. If we don't have two identical angles, then the angles don't sum up to 180. That's not necessarily true, because we could have, for instance, 120 and 60, 95 and 85. Just because the angles aren't the same doesn't mean that you can't have them sum up to 180. So that's not a true statement. All right. So now, let's look at the second one. If two angles sum up to 180 degrees, then the angles are identical. If two angles don't sum up to 180, then angles aren't identical. Again, not necessarily true. Because this one is stating that if the angles don't sum up to 180, they're not identical. Well, 45 plus 45 equals 90, which does not sum up to 180, but they're identical angles. We can have basically 1 to 90. We can have two angles between 1 degree, even like just over point, just over 0 being 0.0001 degree, all the way to 90 degrees, but not including 90 degrees, and have two angles like that. They would be identical, but they do not sum to 180 degrees. So the catch on this one is they don't sum to 180 degrees. Since they don't sum to 180 degrees, they're not identical. That's not a true statement either. So both of these are false statements. All right. So the contrapositive is obtained by negating and reversing. So flip and go from there. If it's raining, this is original statement. If it's raining, there's the if. Then the non-covered parking lot is what? If non-covered parking lot is dry, think say Walmart, then it is not raining. So sometimes it's not. You can just do a little teeny tiny switcheroo of the words, like wet to dry. That's the statement. Is this a true statement? No. There are sprinklers, and there could be other ways that a ruptured fire hydrant, etc., for that non-parking lot to be wet and still not be raining. So that's not really a true statement either. If number is even, then it's divisible by 2. So let's go ahead and swap. Find the if, find the then. In this case, it does have it. If, then. So, if, then. So just swap and negate. If a number is not divisible by 2, then the number is not even. This would be a case of a true statement, because in order for it to be even, it has to be divisible by 2. All right. Pretty simple, pretty straightforward. So the next one we have is if two numbers are odd. Go and give this one a go, and then we'll get to it in a second. Okay? So if two numbers are odd, their sum is even. What do you guys think about this one? Sum, you gotta recall what sum means. Sum means addition, all right? So if two numbers are odd, then when you add them together, the result is even. Can you think of adding any two odd numbers together and not getting an even number? Not really. So let's go ahead and work with this. We're going to negate and change. So we're going to start at the sum not being even, because we're starting with this part. Then we're going to say the two numbers are not both odd. So if the two numbers is odd, well, that's not even. Then both numbers are not odd. Notice we said both numbers. One could be odd, one could be even, or they both are even. They just can't both be odd. In other words, they can't be 1, 5, 1 in, I don't know, 637. Not 2. 635 plus 1,346,733. I purposely entered in the odd value, but there are other ways. Then at least one number is odd. That's more restrictive than this one, because that means one must be odd, and you're eliminating the possibility of them both being even. But you can't really use an even number anyway. So this is more restrictive but more accurate. Because an even plus an even, that will cause it basically to be even. So you need at least one number to be odd. So this, even though this is more restrictive, it's also more accurate. And consequently, we can also say at least one number is even, but this is less accurate because both could be uneven. So I would say the most accurate way to put it would be this one right here. Then at least one number is odd. So you see that there's multiple different ways to go through this, but the best way is to be trying to stay true to what this is saying. These ones could land you into not necessarily always true. The first one and the last one. So you have to bear that in mind when you're going through this. All right? So, with that said, we have gone through these. As you saw, we went through converse yesterday. We went through negation today, inverse and contrapositive. Tomorrow, we're going to go through what's known as biconditional. So this is a preview for tomorrow. The biconditional is when these both are true. Okay? So that's just a little bit of a preview. As you see, this is a preview of tomorrow, biconditional. All right? So this is what we'll be talking about tomorrow. And it's going to be the combination of both P implies Q and Q implies P. All right?